For novel systems operating in an open world, hazard analysis becomes a lot more difficult because there's no way to know you've figured out all the hazards, and there's no way to completely characterize the operational environment. Operating in the open world is a challenge because the real world does what it wants. You can't tell it what to do and what not to do. It's going to do what it wants. You don't know all the hazards at first. Think about if you're trying to characterize different objects you would see in the external world. How do you know what all the objects are? Well, the objects are what they are. You can observe, you can find some, but there's probably something you missed unless you have incredibly long observation periods. So you don't know all the hazards. What do? You test, you test, you test, you test some more until you've uncovered enough hazards. From a process point of view, what it looks like is you have a design cycle that does the hazard analysis up front. You then go into testing. And once you're testing, you find surprises, things you didn't think of in the design. That process tends to be called dealing with the safety of the intended function, SOTIF. So the idea for regular design and hazard analysis, which is called functional safety usually, functional safety is about something that breaks inside the system that you're going to fix. Safety of the intended function is about interacting with the real world. Sometimes things don't operate 100% perfectly, like if there's a radar, sometimes you get a pulse back, sometimes you don't. But more importantly for our purposes, there are requirements gaps. So you operate in the real world, you look at the unknowns which manifest as they're called triggering events. So ISO 21448 is the automotive standard for SOTIF, which will say operate until you encounter something you haven't seen before, an unknown unknown. And then when that happens, it's a triggering event. Feed it back into your design, do the hazard analysis now that you know that's a hazard, mitigate it, and then repeat until you stop seeing triggering events. That's great if you stop seeing triggering events, but what if they keep coming? So this is a little bit of a problem. Nonetheless, this is the approach being taken by many of the autonomous vehicle companies. They're going to go out and they're going to test until they've covered all the things that matter, and that's the SOTIF process. The limitation to this is the residual unknown unknowns. You've driven for 1,000 miles, 100,000 miles, 1,000,000 miles, 10 million miles. But at some point you stop seeing new things you haven't dealt with, and when that happens, you can say it's time to deploy. So the hypothesis behind the SOTIF approach is that you can find enough of the unknowns to get yourself to safety. And if that works, SOTIF will get you there. If it doesn't work, we're going to have to be more careful, and a lot of this talk is how to know that it's working and what to do about cases where it might not work as well as you want it to.